Hey guys, it's Mr. Munoz, of course. Still wrapping up this section on trig. The last skill concept is angles of elevation and depression. You can kind of read here what they are. An angle of elevation, as you can see, is formed by looking up at something. So it's formed by a horizontal line of sight and then another line of sight looking up at something. So that would be your angle of elevation. If I was looking down at something, an angle of depression would be formed by, again, a horizontal line of sight and then the line of sight looking down at something. You can see other examples here. The person looking up at the plane, angle of elevation, looking down at the dog, angle of depression, and so on. There's other examples here. The bird looking at the cat, angle of depression. And this first problem, as you can see, it's sketched out here. It says from a point on level ground, 125 feet from the base of a tower, the angle of elevation to the top of the tower is 57.2 degrees. Sketch the problem and approximate the height of the tower to the nearest foot. So here's my sketch. It says there's some point on the ground 125 feet from the tower. That's this. Obviously, this is the tower. It says the angle of elevation up to the tower is 57.2 degrees. So again, that's a sketch of the scenario. And on that note, how tall is the tower? Well, how tall is the tower is going to be it's going to be this length here, but it can be found using trig. So that's the whole point of this lesson, that you can still use trig here to find these unknown measurements, angles, or lengths. So here it ends up being tangent. Honestly, a lot of these angle of elevation and depression problems, for whatever reason, end up being tangent. They don't have to be. They're not always tangent, but a lot of these come out tangent, not cosine or sine. So on this one, that's what it is, because it's from here, from your angle of elevation, your opposite side is actually going to be the height of the tower. Your hypotenuse is here, and then your adjacent side is going to be the 125. So remember, tangent equals opposite over adjacent. So over here, tan of 57.2 equals h over 125. Right here, you want to get this ratio from your calculator or the trig table that that I gave you, and it's 1.5517. And once I get that, I want to put a 1 under it and cross multiply. And so I ended up getting the height is equal to 193.96, so about 194 feet tall for the tower. The next problem is pretty much the same thing. It's talking about the Eiffel Tower, but literally the exact same concept. A point on the ground 80 feet from the base of the tower. Oh, and by the way, these are right triangles that we're looking at still. Like if it went straight down from the center of the tower, you'd end up having a right angle here. So that's why this still makes sense, because it is right triangle scenario. So this one says angle of elevation is 85.4 degrees up to the top of the tower, and it says that is from a distance that's 80 feet from the base of the tower on the ground. And the fact that it says on the ground is how I know to like definitely put it here. And then how tall is the tower? Well, it ends up being from the angle opposite side will be this. So that basically the tower's height represents the opposite side. The distance on the ground, 80 feet, is my adjacent side again. And then I have my hypotenuse. I didn't even label them because that's kind of where I would want to be after a few days of using trig. I'd want to be kind of just able to do it without labeling. But if you labeled it, you'd say opposite here, hypotenuse here, adjacent there, and of course use these two sides because you know this side length and you need this one. So using these two, opposite and adjacent, tangent. So it ends up being the same setup pretty much as the previous problem. Tan 85.4 equals opposite over adjacent, and the tan ratio for 85.4 is 12.4288. Put a 1 under it, cross multiply, and I get my unknown measurement is about 994 feet, which actually is not too far off from the actual height of the tower in real life. So pretty good estimate. And then these next two problems, example 5 and practice 5, they give me both lengths and they say find the angle. So Again, pretty much the same type of sketch. It's there's a building 21 meters tall. Here that is, you can see that. The shadow, it says it casts a shadow 25 meters long. And how, or what is the angle of elevation from basically up to the sun, because the shadow would obviously be cast by sunlight. So again, from here you have your opposite, hypotenuse, and adjacent. The two sides I know are opposite and adjacent, so tangent ends up being the ratio I use again. And of course, from previous lessons, if you take a tan ratio and you want the angle measure, you have to use the inverse. So I'm straight into the inverse here. Tan, remember the negative one means inverse, and the inverse of 0.84 tells me that, if you look it up on the table or a calculator, tells me the angle's 40 degrees. And then the very last one here, same type of scenario. This one says a flagpole is 14 meters tall. The shadow that it's casting is 10 meters long. And what's the angle of elevation up to the sun? And so that's going to be this angle here. And again, it ends up being opposite and adjacent. So tangent again. If I know two side lengths, I can use my tangent inverse ratio to get the angle measure, right? 14 divided by 10 is the actual ratio. Look up the inverse of 1.4 basically, and it'll tell you 54.46. So the angle's 54 degrees. So try a few problems. Hopefully you can use this video to help a little bit. And yeah, there's some practice problems down below, well, where it says practice. So thanks for having a listen.